Today we're going to look at absolute value graphs a little bit more in detail. And we need to go backwards and talk about what the definition of absolute value is. And it's a real number, regardless of its sign. What I most often say for the definition of absolute value is it's the distance that a number is away from zero. If you're in room 2003, there's a green poster in the back of the room that says that absolute value won't put up with negativity. And that's what's nice about the absolute value. It says the absolute value function works just as the definition describes. You put a number into the function, and the output is your number without the sign. So in other words, absolute value won't put up with negativity. Positives will stay positives, and negatives will become positive, because we're measuring distance, and distance is never measured with a negative number. Remember also that absolute value is a V shape when we draw the graph. And below what you see here is the list of some of our key points on our absolute value parent function. But what happens if we take the absolute value of the entire function? And that's what we're going to look at here today for a little bit. So let's look at a basic parent function here, and it's y equals x. And depending on how oriented the board is, if I draw the picture here of y equals x, we know that it's the graph that goes from the lower left hand of the graph to the upper right hand and through 0, 0. And unfortunately over here, the board is slightly disoriented and it will not let me go from corner to corner. But the points that I just drew, and in fact I'm going to have to try to draw that one more time. 0, 0. 1, 1, 2, 2, negative 1, 1, negative 2, 2. And not much better, but maybe a little bit better. I'm really sorry. Why don't we list those points just so you know that a couple of values that we put on here. We have negative 2, negative 2. And we have negative 1, negative 1. We have 0, 0. Positive 1, positive 1, positive 2, and positive 2. And over here, here is our absolute value function. And what we get here is we've got the point 0, 0, 1, 1, 2, 2, negative 1, 1, and negative 2, 2. We'll make a table of this, but we're pretty familiar with that graph. And when we look here, we have negative 2, positive 2, negative 1, positive 1, 0, 0, 1, positive 1, 2, positive 2. So we took the absolute value of the entire function. And what's happening here is that when we take the absolute value of a negative number, like the absolute value of negative 2, we get positive 2. Or the absolute value of negative 1, we get positive 1. So in other words, well, let's keep going here before I really point out what's happening in the graph. So let's look at number 2. And I know that we know how to graph y equals x cubed, but let's look at it on the calculator. So if we go to y equals, and we type in x cubed, then we look at our picture, we get that picture. And if we need to, our table is here, and I'm going to change it up just a little bit. And here's our values for our table. So when we come over here and we draw the picture of this graph, I usually start at 0, 0, 1, 1, 2, 8. Negative 1, negative 1, and negative 2, negative 8. And there's a rough picture. Well, what happens now if we take the absolute value of that entire function? Well, let's go back to our calculator, and I'm going to turn this graph off for a minute, and let's do the absolute value of this function. By the way, we use math, and then number, and 1. So we're going to do the absolute value of x cubed. And let's look at the picture. We should only see one graph. And there's a picture. Well, let's look at the table here and see what our points are so we can compare this. So here's some points. And what we have is we have -2, 8. We have -1, 1. We have 0, 0. We have +1, 1. And we have +2, 8. Looks like that. Well, if we put these together on the calculator, in other words, if we graph them both on the same screen here, so I'm going to turn back on this first screen, first graph. The blue graph is the original y equals x cubed function. And what you, I hope, can see here is when we took the absolute value of that entire function, it took what's below the x-axis and it reflected it over the x-axis so that we were only dealing with positive values. So this blue value below the x-axis turns into the red value above the x-axis. Let's try another one. So we have to flip our page over. Y equals x squared. Again, we're familiar with that graph, and we should be able to graph it without too much trouble. But let's clear those out and type in y equals x squared. And we can look at our picture. Again, we know what those values are, but let's look at the table as well for comparison purposes. And here's our table. But realistically, what we're drawing is we're drawing 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. So there's our quadratic graph. And the question now is, well, what's going to happen to this graph when we take the absolute value of the function? So once again, I'm going to turn that graph off for a moment, and we're going to go to math and number and 1 for the absolute value. Then we get x squared, and let's see what it looks like when we graph it. Well, it looks remarkably the same as what we saw before. And let's just verify that it's the same or not by going to second and graph, which gets us up to the table value. So we can look at this table over here for comparison purposes. And what we have in our graph is we have -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And although my picture is weak at best, as we look down below each of these graphs, we see the same values on our table. And what happens here is when we take the absolute value of the x squared, y equals x squared, we did not have any values below the x-axis in the first place. So we didn't have to turn anything into a positive value because we're taking the absolute value of a function. So nothing changed in this particular case. But that's not always the case. And by the way, let's just take a quick look with both of the graphs at the same time. If I turn that one back on, sure enough, the blue graph, which was our original function, landed on top of the red graph, which was already graphed there, our absolute value function, and they ended up to be the same value. So let's look at y equals 1 over x. Maybe have a little bit of a difference here. So we're going to go over here to y equals, and let's clear these out. And then alpha y equals 1 over x. Got to get that 1 in there. And we'll draw the picture. So there's a rough graph. Eventually what we want to do is we want to be able to draw these without a calculator. But we're exploring. We're trying to figure out the pattern here when we're graphing an entire function we're taking the absolute value of. And I will draw the picture, but I'm going to take the table here and put it underneath so we can see that. But our points here that aren't all listed on the chart on our table, we usually start with 1, 1. We also have 1/2, 2, and 2 1/2. If you look back at your key points on your parent function notes. And then we've got negative 1, 1, which also includes negative 1/2, negative 2, and negative 2, negative 1/2. And although my picture doesn't look like it, we're not supposed to touch the x-axis or the y-axis. So go back and look at your screen there again, just to be clear. And it doesn't touch the x-axis or the y-axis on here, even though it looks like it does. We've talked about that before. But now I wonder what's going to happen when we take the absolute value of the entire function. So we go to y equals. I'm going to turn this one off for a moment, and let's put the absolute value in. And again, it's math, number, and 1. And then alpha y equals to get our fraction of 1 over x. And maybe by now you might be seeing a pattern so that we can use to help us draw a graph without a calculator. And hopefully that's what you thought was going to happen. So let's look at the table, and for comparison purposes. But I haven't really pointed it out, and I do want to point it out a little bit more here. If you notice, we had negative 3, negative 1/3 in the original function, but now we have negative 3, positive 1/3, because we took the absolute value, and the absolute value doesn't put up with negativity. We had negative 2, negative 1/2, but because we took the absolute value, now it's positive 1/2. We had negative 1, negative 1. We took the absolute value. Now it's negative 1, positive 1. And so forth there. And then we can draw our picture here, and the right side of the graph isn't going to change. We still have positive 1, 1. We have 1/2, 2, and 2 1/2. That part of the graph isn't going to change. But over here on the other side, we have negative 1, 1, and we have negative 1/2, 2, and we have negative 2 1/2. And there's our picture. And once again, look at it on your calculator. The color calculators actually show this quite well. When we go back to y equals and I turn this function back on the graph, our red function's already there. But there's the original. The blue was the original. And what happens is we reflected the values that are underneath the x-axis. We reflected it over the x-axis because we're dealing with the absolute value. So now what I would like you to work on is I would like you to try some without a calculator. So if we look at problem number 5, which is the last one that I'm going to do on the video, at least for now, it says, can you predict what will happen to the following functions? Now try to graph both the parent function and the absolute value of the parent function without your calculator. And then, of course, check your graph by using your calculator. So I'm going to scoot these over here a little bit just to see if I can stay away from the disorientation and make them a little bit bigger. Oh, nope, we can't make them a little bit bigger. All right, but we'll try that. Scooting them over. And so if we graph y equals, the y equals the cube root of x. I don't know why that happened. All right, scoot that there. So, you know, 0, 0, 1, 1, 8, 2, negative 1, negative 1, and negative 8, negative 2. There's our parent function. Well, the thing is, when we're taking the absolute value of that function, what's going to happen is that any points below the x-axis are going to go above the x-axis. So the 0, 0 and the 1, 1 and the 8, 2, they're not going to change. That's still there. But what's going to happen now is that the negative 1 is going to become negative 1 positive 1 because we took the absolute value. And the negative 8 negative 2 is going to become negative 8 positive 2. And there is now the graph of the absolute value of the cubed root of x. What I'd like you to do for the remainder of the time is to continue to work on these functions. Try them without your calculator.